Good morning, students. Today we are going to discuss uh, differentiation part 1. You already learned this topic in standard 11 and 12. Okay, so we just take a short look on this topic. Can anyone tell me what is differentiation? Can anyone tell me what is differentiation? You can give your answer in your own words. No need to give answer in the perfect definition. Anyone? What is differentiation?
Ma'am, dividing each term of polynomial in small parts.
Okay. Anyone else? Yes,
A
Kushal.
function.
Yes. Yes, Kushal.
Change in x-axis with respect to y-axis or change in y-axis with respect to x-axis.
Rate of change of function.
Okay. Okay. Yes. Students, rate of change of function is also right. Differentiation is a process in maths where we find the instantaneous rate of change in function based on one of its variable. The most common example is the rate of change of displacement with respect to time, that is velocity. If x is a variable and y is another variable, then the rate of change of x with respect to y is given by dy by dx. This is the general expression, right? So we can say that differentiation is nothing but it is a rate of change with one variable with respect to another variable, right? So let's take some formula of the differentiation. First is x raised to n and x raised to n minus 1. The next one is exponential functions. Dear all, you all know that there is no change in the exponential term. So the derivative of e raised to x is e raised to x itself, right? The derivative of sin x is cos x. Similarly, the derivative of log cos x is 1 upon x. A raised to x, a is any constant. So derivative of a raised to x is a raised to x into log a, where base is e. The derivative of cos x is minus sin x. Derivative of tan x is sec square x, and the cot x is minus cos x square x. Sec x tan x, derivative of cosec x is minus cosec x cot x, right? The derivative of sine inverse x, that is 1 upon under root 1 minus x square. And cos inverse x is just, there is a difference of sine, minus 1 upon under root 1 minus x square. Both are same, but the derivative of sine inverse x is positive and the derivative of cos inverse x is negative. The derivative of tan inverse x, that is 1 upon 1 plus x square, where the derivative of cot inverse x is minus 1 upon 1 plus x square. Dear students, this is the multiplication rule. U dot v, where u and v both are function of x here. U is a function of x. Here, this u is a function of x and v also function of x. So when we have two function of x and we want to the derivative of that function, then first we have to keep u, keep it the same, the derivative of v plus v, keep it the same, and the derivative of u. The derivative of u by v. Here, this one is the multiplication rule, this one is the division rule. For the division rule, we have to square of the denominator, then keep the denominator same, derivative of the numerator, minus, keep the numerator same, and the derivative of denominator. This is the multiplication rule, this is the division rule. Both rules are very important for the next lectures. So, these are the basic and important formula for the differentiation. So, with the help of this formula, let's start some examples. Let's start with the first example. F of x is equal to x cube. Dear all, you all know that x cube, that is the type of x raised to n, and the derivative of x raised to n is n x raised to n minus 1. So the derivative of x cube is 3x square. Similarly, if we take the derivative of x raised to 5, then we have 5x raised to 4. If we have the derivative of x raised to 100, then we have 100 x raised to 99, like that. The next one is e raised to x cube. This is the exponential function. And we all know that the derivative of exponential function is the same. So first the f of x, this one is f dash x. So this is the derivative. So e raised to 3x, keep it the same. And then applying the chain rule, the d by dx of this power. So d by dx of 3x, that is 3. So 3 e raised to 3x. So similarly, if we have given e raised to 9x, then what? Then if our function is e raised to 9x, then derivative is e raised to 9x, keep it same. And by applying the chain rule, the derivative of 9x is d by dx of 9x, that is 9. So 9 e raised to 9x, right? The same way, dear students, e raised to sin x. This is again the exponential function. So e raised to sin x, keep it same. By applying the chain rule, d by dx of sin x, that is cos x. So our answer is cos x e raised to sin x. The next one is 3 raised to x. 3 is the constant term. So here we are applying a raised to x, where a is any constant. So the derivative of a raised to x is a raised to x into log a, where base is e. So 3 raised to x, the derivative of 3 raised to x is same, 3 raised to x into log 3, where base e. We have just replied a by 3 here, right? Now, the next example is from the logarithm, that is the log 5x, right? So, log 5x, for log 5x, this is the log, and we know the derivative of log is 1 by x. So, this is our theta, x is our theta. So, 1 upon theta. Here our theta is 5x. So 1 upon 5x. Then apply chain rule. So d by dx of 5x, that is 5. Both 5 will be cancelled. So our answer is 1 by x. Now the next, log x raised to 4. Okay. So for log x raised to 4, this is again the logarithm functions. And this is our, x raised to 4 is our theta. So we have to put 1 upon theta. So 1 upon x raised to 4. Then apply the chain rule. So d by dx of x raised to 4, x raised to 4. So here we are applying x raised to n rule, that is n x raised to n minus 1. So 4x cube, and x cube upon x raised to 4, that is 1 by x. So 4 by x is our final answer. The next one is, our function is tan 8x. 8x is our theta. The derivative of tan x is sec square. Here sec square x. So the derivative of tan is sec square 8x, that is theta will remain the same. So sec square 8x, and by applying chain rule, d by dx of 8x, that is just 8. So by the simplification we get the answer 8 sec square 8x. The next one is the next one is tan x square. The students, remember, both are the different tan square x and tan x square. Both are different. For 10 square x, first you have to do the x raised to n rule, that is 2 tan x. Then you have to do the derivative of tan x, that is sec square x. But for tan x square, this is our function, this one is our theta. So this is our theta. So the derivative of tan is sec square, theta that is x square will remain same, and by applying chain rule, d by dx of x square, that is 2x. So our final answer is 2x sec square x square. Sin x cube. Sin x cube, sorry, sine cube x, that is not sine x cube, this is sine cube x. As I told you, this is the power of the function. So first we have to apply x raised to n rule. So 3 sine square x, and our original function is sine x. So by applying chain rule, d by dx of sine x. This is the most important example because many students are making mistake in this type of example. 3 sin square x, keep it same. The derivative of sin x is cos x. Okay. So final answer is 3 cos x sin square x. Similarly, if I take sin raised to 4x, right? Then my answer will be, first I have to apply x raised to n rule. So 4 sin cube x, then d by dx of sin x. So 4 sin cube x into cos x. Similarly, if I take 10 square x, then what? Then again 2, this is 10 x square, this is 10 square x. So 2 10 x and d by dx of 10 x, that is sec square x. So 2 10 x sec square x, 2 10 x sec square x, right? Yes, Dev, there would be d by dx into x in n2, right? Yes, yes, you are right. There would be d by dx of x in n2. So it means we have to do the derivative up to the n, up to the theta. So if our theta will be x, then d by dx of x is 1. So no need to write that 1. But if our theta is 5x or x square or any else then x, then we have to do the we have to write that derivative here. Cos cube 5x, see, cos cube 5x. So first we have to see, this is the power of the function. So first we have to apply x raised to n rule. So 3 cos square, one power will be less. So 3 cos square 5x. Then our original function is cos 5x. So d by dx of cos 5x after applying the chain rule. So 3 cos square 5x, d by dx of cos 5x, that is minus sin 5x, and our theta, that is 5x. If it is only x, then no need to write here d by dx into x, that is the 1. But here 5x, so d by dx of 5x is 5. So our final answer is minus 15 sin 5x cos square 5x. Dear students, for the example 11, sin tan x. This tan x is our theta. Our function is sin. So the derivative of sin is cos. Theta will remain same. So the derivative of sin x is cos. Theta remains same. So we have tan x. And then applying the chain rule, d by dx of tan x, that is sec square x. Okay. So cos x tan x into sec square x. Actually, here d by dx of this theta, that is x, but d by dx of x with respect to x, that is 1. So no need to write this step. Now, the next, e raised to sine x cube. E raised to sine x cube, this is again a exponential term, exponential function. So we keep the same, that is e raised to sine x cube. Then applying the chain rule d by dx of this power, that is sine x cube. Here sine is our function, x cube is our theta. So the derivative of sine is cos, theta will remain same, and then applying the chain rule d by dx of x cube, that is 3x square. So our final answer is 3x square cos x cube into e raised to sine x cube. Now, now the next sum is e raised to x 10x. Student, this is little bit different from the previous example. In this example, there are two terms which contain x. So this is our u, this is our v. This is the function which contain x, that is e raised to x, and the next one is tan x. So we are applying multiplication rule u dot v. I already told you u is a function of x and v is also a function of x. So you keep it the same, derivative of v, that is dv by dx, plus we keep it the same, and the derivative of u, that is du by dx. Now this is our u. So you keep it, u is e raised to x, so e raised to x keep it the same. Derivative of tan x, that is sec square x. Now we keep it the same, and derivative of e raised to x, that is e raised to x. By taking e raised to x common, our answer is tan square x plus tan x. In the next example, again sin x is u, log x is v. So put sin x, keep it same, derivative of log x plus log x, keep it same, and the derivative of sin x. So the derivative of log x is 1 upon x, and here derivative of sin x is cos x. So after simplification, we get sin x upon x plus cos x into log x. The next example, our u is log x, v is sec x. So log x, keep it same. Derivative of sec x, that is sec x into tan x. Sec x, keep it same, and the derivative of log x, that is 1 by x. So log x, sec x into tan x plus sec x upon x. Now, the next, this one is, here u is e raised to 5x, v is tan 3x. So e raised to 5x, keep it same. The derivative of tan 3x, so tan is our function, 3x is our theta. So the derivative of tan x is sec square, theta remains same, so sec square 3x. By applying chain rule, d by dx of 3x, that is 3. And for the second term, tan x, keep it same. The derivative of e raised to 5x, this is exponential function. So e raised to 5x, keep it same. And by applying chain rule, d by dx of 5x, that is 5. So after simplification, we get the answer e raised to 5x, 3 sec square 3x plus 5 tan 3x. Dear students, in the example number 17, there are three terms which contain x. See, e raised to 3x, sin x, and log x, right? In this example, e raised to 3x, if we e raised to 3x sin x, if we take these both as a u and this one as a v, then e raised to 3x into sin x, you have to put in one bracket, log x in the another bracket. This is not f dash x, this is just fx. Now this one is f dash x. Now first, u keep it same. So e raised to 3x sin x, keep it same. Derivative of log x, d by dx of log x. Plus log x, keep it same, and d by dx of e raised to 3x sin x. E raised to 3x sin x, derivative of log x is 1 by x. Log x, keep it same. In this bracket, again you have two functions which contain x. So e raised to 3x is your u and sin x is your v. So e raised to 3x, keep it same. The derivative of sin x is cos x. Sin x keep it same. And the derivative of e raised to 3x, that is e raised to 3x, and by applying chain rule into 3. So final e raised to 3x sin x into 1 upon x log x e raised to 3x into cos x plus sin e raised to 3x into 3. Students, we can do, in mathematics, we can do one example in more than one method. But here I am trying to explain you the multiplication method. So we are doing this method. Okay, you can also do this example by other method also. The next one is x square tan inverse x. X square is u, tan inverse x is v. X square keep it same. The derivative of tan inverse x is 1 upon 1 plus x square. Tan inverse x keep it same. And the derivative of x square, that is 2x. By getting x common, our answer is x upon 1 plus x square plus 2 tan inverse x. Now, the next one is e raised to 2x sin inverse x. E raised to 2x sin inverse x. So e raised to 2x is our u, sin inverse x is our v. U keep it same. The derivative of sin inverse x plus sin inverse x keep it same, and the derivative of e raised to 2x. So the derivative of sin inverse x is what? 1 upon under root 1 minus x square. The derivative of e raised to 2x is e raised to 2x by applying chain rule into 2. By getting e raised to 2x common from both the term, we have 1 upon under root 1 minus x square plus 2 sin inverse x. Similarly, for the example number 20, here our u is sin x square and v is log 3x. So u keep it same, sin x square keep it same, the derivative of log 3x plus log 3x and the derivative of sin x square. Sin x square keep it same, and the derivative of log 3x, that is 1 upon 3x, and by applying chain rule, the d by dx of 3x is 3. Log 3x keep it same. The derivative of sin x square. Sin is our function, x square is our theta. So the derivative of sin is cos. X square remains same, that is our theta. And by applying chain rule, d by dx of x square, that is 2x. So both 3 will be cancelled. So sin x square into 1 by x, this is 2x log 3x into log x square. Now, sin cos x and e raised to 3x, right? So sin cos x, this is u, e raised to 3x is our v. Dear students, this sin is our function and cos x is our theta. So sin cos x keep it same. The derivative of e raised to 3x plus e raised to 3x keep it same, and the derivative of sin cos x. Now the derivative of e raised to 3x, this is the exponential function. So e raised to 3x, and by applying chain rule, d by dx of 3x is just 3. Here e raised to 3x keep it same. The derivative of sin is cos. Theta will remain same. And by applying chain rule, d by dx of theta, that is d by dx of cos x, that is minus sin x. And by getting e raised to 3x common from these two terms, the remaining term is 3 sin cos x minus sin x into cos x. Okay. Students, now we are moving for the example with the help of the division. Here, this is the division rule. In this case, here e raised to x is our v. E raised to x is our u and sin x is our v. See, u by v rule, that is the division rule, and for applying u by v rule, first we have to do the square in the denominator, then put denominator v, keep itself, and then now for applying division rule, this is v square. V keep it same, the derivative of u minus u keep it same, and the derivative of u. So, this is our v. V is our sin x. So, sin x whole square. Sin x keep it same, the derivative of u, that is e raised to x, minus e raised to x keep it same, and the derivative of sin x. So sin x, derivative of e raised to x is e raised to x, minus e raised to x, the derivative of sin x is cos x. So if we keep e raised to x common, sin x minus cos x upon sin x whole square, right? The next, u by v, again v is tan x, so tan x whole square, tan x, we keep it the same, the derivative of log phi x minus u, log phi x keep it same, and the derivative of v, that is d by dx of tan x. So derivative of log phi x is now 1 upon phi x into phi, and here the derivative of tan x is sec square x. So by simplifying, we get tan x upon x minus log phi x into sec square x upon tan x whole square. The next example is x raised to x. What about x raised to x? If we have given one x function and in the power there is also x functions, then we put this function as e raised to log base e x raised to x, right? And after applying the logarithm rule, we also keep this x power as e raised to x log x, where base is e. So, x raised to x, we put in the form of e raised to log x raised to x by applying the logarithm rule, e raised to x log ex. Now, this is our exponential function. So, derivative of e raised to x log x, keep it same. Then applying the chain rule, d by dx of log x into log x, this x is our u, this log x is our v. So applying u into v rule, x keep it same, the derivative of log x is 1 by x, then log x keep it same, and the derivative of x is 1. So our final answer is x raised to x, 1 plus log x. The next, x raised to sin x. This one is again the same. Our base is function of x. Power is also function of x. So we keep this term as e raised to log x raised to sin x, and we also write as e raised to sin x log x, right? All three functions are same. So e raised to sin x log x. So this is the exponential function. So the derivative of the exponential function is the same. So e raised to sin x log x by applying the chain rule, d by dx of sin x log x. By applying u into v rule, multiplication rule, sin x keep it same, the derivative of log x is 1 by x, then log x keep it same, and the derivative of sin x, that is cos x. So this one is x raised to sin x upon x plus log x into cos x. The next, sin x raised to x. Okay, so sin x raised to x. This is our function, this is our theta. So first derivative, the derivative of sine is cos. X raised to x, theta will remain the same. And then the derivative of x raised to x, cos, and the x raised to x. Then apply the chain rule, derivative of x raised to x, which we already learned in example number 24. So we keep this x raised to x in the form of e raised to log x raised to x, and this one is also written as e raised to x log x. Okay, so this one is the exponential function. So the derivative of exponential function is the same. So e raised to x log x, and by applying chain rule, d by dx of x log x. So by applying chain rule, we get the answer x into 1 by x plus log x into 1, that is 1 plus log x. So our final answer is cos x raised to x. This one is x raised to x and 1 plus log x. So this is the answer of the given example. Dear students, let's take pen and paper. We'll do some more example. I will ask the particular students and particular student will give the answer. Okay. I will ask the particular students and particular students will give the answer. Please don't unmute yourself till I ask you. The first one, e raised to y is equal to e raised to 10x. E raised to 10x. Yes, Bhargav? Yes, Bhargav?
Yes, ma'am. It's e raised to 10x
Yes.
dot x square x.
Yes, good. See, this is the exponential function. So e raised to 10x, keep it the same, and the derivative of 10x is x square x. Okay. See, this is x. So there is no need to write the d by dx of x. The next is e raised to sorry, y is sine square 2x plus 1. Sine square 2x plus 1. Yes, Abhi? Yes, Abhi?
dy by dx equal to 2 sin x bracket 2x plus 1
Yes.
into cos bracket 2x plus 1
Yes.
into 2.
Perfect. See, thank you. 2 sine 2x plus 1. The derivative of sine is cos. Angle will be the same. And the derivative of this theta is 2. So we keep this 2 sine theta cos theta as sine 2 theta, right? So sine 2 theta means 2 into 2x plus 1. This 2 will keep in the forward. So 2 sine 4x plus 2 will be our final answer. Thank you. Next, e raised to y equal to sine log x. Yes, Nirmal. Yes, Nirmal.
Cos log x into 1 upon x.
Perfect. The derivative of sine is cos, log x will be our theta, so it remains same. And by applying the chain rule, the derivative of log x is 1 by x. Okay. Now, e raised to 3x, y equal to e raised to 3x into cos 2x e raised to 3x into cos 2x. Yes, Tanvi. Yes, Tanvi.
e raised to 3x
Yes,
into sine 2x into 2
yes,
plus
yes.
cos 2x into e raised to 3x into 3.
Perfect. See, here,
There will be minus
Ma'am,
no,
minus
no.
sign.
Ma'am, minus
minus sign.
e raised to 3x minus sine 2x.
Yes, 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 yes.
Yeah.
The derivative of cos is minus sine 2x. So e raised to 3x. The derivative of cos is minus sine 2x into 2 plus cos 2x will remain same. And the derivative of e raised to 3x into 3. Okay. Thank you, students. Now, the next example is tan square to 3x. Tan square 3x. Yes, Kushal Trivedi. Kushal,
2 tan 3x into sec square 3x into 3.
perfect. See, 2 tan 3x, the derivative of tan is sec square 3x, and the derivative chain rule 3x is 3. So our final answer is 6 tan 3x into sec square 3x. Students, our today's lecture will conclude very shortly. Before we continue the next example in tomorrow's lecture, but